We don't record them that much. We just do them live.
It's really awful.
Yeah.
Do you want the carrot?
No, thank you.
They're gonna keep giving you food. They're Peruvian. I was
Nah.
just telling you that.
No, it's fine. Thank you.
All right, thank you so much.
Yeah.
And tomorrow.
Tomorrow.
Here, great, perfect. I'm here all day.
So 3, 6, 10 plus male.
3, 6, 10 plus male. So we're going to talk about and or. Right? So just the other. So or is this pipe thing. Right? So I call this a pipe. And that is. So if you look on your keyboard, at least for mine, it's under the delete key. Right? You have to hold shift. It's actually just a straight line. So top should be on the top right of your keyboard.
Yeah.
You should have it somewhere.
Remember, it's a Spanish keyboard.
It's got to be somewhere. So your brackets. Actually, it might be that. That one next to the right of the one.
To the right of the.
Like no, that thing. You know what I'm saying? I don't know how you get that.
No. It's not that.
It's not that.
Like this.
Try and look at text file. Oh, there you go.
Oh,
That's
yes.
it. Yeah,
It's not
that's the pipe.
Thank you.
So the other one's the ampersand or the and so this is for and, right? So
Yes.
ampersand is for and. So you want that and gender.
But I would want with the percentage in percentage, right?
Oh yes, of course, yeah. Good point. There you go. See? I was testing you, you got no. So there you go. 3, 6, or 10 and they're male.
Can you remind us again how you export this table to Word?
So we haven't talked about exporting yet.
But you showed us yesterday how you
So
your results in Word.
yes. So that is a little bit different, but as there's every read function, read.csv, there's a write.csv.
Right?
Write.
Okay.
Like write.csv.
Oh.
Mm-hmm. So like what and so like how in read.csv it gives you out a data frame, right? When you read it in, the thing you assign it to is a data frame. When you say write.csv, you give it a data frame and it writes it out as a CSV onto the hard disk. So for example, let's say males, young or whatever. And I say males young, so this is a data frame. And I want to write.csv, right? And so X says the object to be written, and it said it'll coerce it to a data frame. So if you pass in something that's not a data frame, it'll make it one. And then file, I'm just gonna put it on my desktop, just something that we can look at really quickly that I'll trash later, right? So I say write.csv, data frame, that. Let me go to my desktop. So it gives me that, but one thing you should note, by default, it includes the row names of the data frame. So in some instances, you actually want this. Many times you don't. Sometimes, so we're going to talk about other, so right, we know what the column names of a data frame are, right? There are variable names. But sometimes the row names can be, for example, names of people, right? But it's usually you have that as a separate column, but sometimes you can have it not as a column. So one example that we actually have had is you have a matrix of birth rates, right, over 100 years or something like that, and the first row or the first column is actually the names of the countries, right? So every single data point in there is a birth rate, other than the very first column, right? So each column is a year, right? So there's 100 columns, and there's, let's say 50 countries or something like that, where you don't necessarily want to keep that first row in there. You could actually label the rows of it to the country name and then you can do different subsettings. So that will, all right, we will move on a little bit, and I'll tell you that if you don't want this, right, you can just say row.names equals false. Okay, and let's open this back up. And those will just be the columns that you want. All right, so age and gender.
No rows.
Yeah, no row names. So let's go through Module 3 really briefly because we did discuss the majority of these things. We talked about functions. I have spoke a little bit about length. So length, when I said, remember I said y, right? Y is all these fun ages, right? So the length of y just says how long is it? How many elements does it have, right? And we already know it should be 10, so we get 10, right? So remember df is a data frame. If you say length on a data frame, it means something different. It doesn't mean how long is it. It means how many columns are there. It means how many columns are in the data frame. But before, yesterday I showed you nrow and ncol to actually get you, if you want the number of rows or the number of columns. Those are very important counting tools. Right? There is a third option which will work for dimensions. Right? Now, like I said before, vectors are one-dimensional. They don't have rows, they don't have columns. They're just one thing. So if you say nrow on y, or or ncol on y, or dim on y, it doesn't understand what you're saying because it says this isn't anything more than a one-dimensional thing. It doesn't have rows, it doesn't have columns, it doesn't have dimension, it just has length. So that's another thing that's a little bit confusing, and we'll talk about what this null thing is, but it's just saying it doesn't have it. Right? It doesn't have rows, doesn't have columns, therefore it doesn't have dimensions in that respect. So, kind of technical things, but like when you're in a data frame and you're like, oh, I can run nrow ncol, and then you, for some reason, you get a vector and you like try to run it and you get this weird stuff. That's why. It's because for vectors, so vectors use length. Data frames or matrices, you can use nrow ncol. Does that make sense? Because it has rows and columns. Okay. So, we've talked about the classes. So, characters, numeric, integer, factor, logical. We will talk about factors again in way more detail than right now. But one thing you should note, what is the class of X? Is it character, logical, integer, numeric? So when you see quotes around something, it means it's a character. Although that is a number, R sees that. So if I say X plus 4, what do you think is going to happen? Error. Because it's going to say, I don't know how to add a word to 4. Right? If you say, again, if we say class X is character. Okay? So there are ways to do what you want to do and change that back into a number. And this is why you should know, it's important to know the names of the classes because there are functions that will convert them. I'll call these the as functions because there is as.numeric, as.character, as.integer, as.logical, for example. Right? So if I say as.character 5, that'll give me 5. But the thing you should note, right, before you have to even write class on anything, for example, if I say X, and you see when it prints out that it has quotes, you should know it's a character. When it doesn't have quotes, for example, like in this one, it is a number. Right? And again, I'm not going to get into it. Almost never do you really need to worry about integers versus numerics in a lot of respects. Right? Whether it's a whole number or not. Okay. So we spoke very briefly about the as functions, right? But some things still don't make sense, right? If you say X is 5, the word, quoted, and you say, I want to turn that into a logical, R says, I have no idea what you're trying to do. That doesn't make any sense to me. So I'm just going to say it's missing. Right? If you try to say, you're forcing me to make this thing into a true or false, and I don't know what to do, I'm going to say, I don't know, it's missing. If, for example, though, let's say you imported something from Excel, and you actually had the word true or false in there. What do you think? So R understands that although this is quoted, it has the word true in it. I understand. I understand what you're saying. You want to turn that actually into logicals, trues or falses. Okay? Right? And so logicals are really important, and it was important in some respects to show you that it treats it kind of as ones and zeros because when you there are ways to make categorical variables in your data sets for like modeling purposes and stuff like that, and we'll get to that. But if you have a logical 0, 1, if you have something that just says true or false, and you put it in a model, R is going to say, okay, I understand. It's like a 0, 1. It's a binary variable, and it'll still be okay in like in a linear model, for example. Right? You'll still have a beta for that coefficient or for that covariant. Does that make sense? Okay. So factors are special, and they're just, again, I'm skipping them because they get a little bit confusing off the bat. So again, data frames are like matrices, but data frames can hold multiple things. So for example, column 1 was ages. Column 2 was gender. Right? 1 was a character, 1 was numeric. Right? So let's do class df age. Right? These are different classes. Again, it's a factor, but and I'll get to what that means. It's a character. Okay, so a factor is a character that has levels associated with it. Okay, so think of categorical variables. Okay, gender is a very easy one to go with. In this case, gender, it's M's and F's, right? So it has 2 levels, male and female. If you make something a factor, and you don't tell it what levels, how you want it to be ordered, it automatically assumes you do it in alphanumeric order, right? So it always puts female first because it comes before F becomes before M, and you know women come first. That's the way it is. So there's a factor function. So factor will take in a character, turn it into a factor, and then output that factor. And factors have different things than characters. So if I say, what are the levels of that factor? It'll tell me. Okay? And if I say table on that factor, it's going to operate almost identically to if you did it on a character, right? It's going to table them up. So how many M's, how many F's. The difference with it is, let's say df sex2, and let's say I wanted to, for example, in my coefficient table, I wanted it to actually be males to be the reference group. Okay? So for some reason, I want males to be the reference group. Okay? I can say, factor, make this thing into a factor, and these are the levels I'm giving you. Okay? So make me a categorical variable. Make me something that R will understand that it's not a number, it's not a character, it's actually a categorical variable with separate levels.
Okay, so by giving it levels, you're turning it into a categorical.
So factor on its own will turn it into a categorical variable, but if you want to specify right, so let's say for example, you did a survey and you did marital status for like single, divorced, widowed, married, for example. But you want one of them to be the reference group. And you don't want it to automatically go with alphabetical order. You would specify the levels. So now I'm just going to say, so the table, when you run table, right, what it will do on a character, it'll give you the levels in alphabetical order, and right. So we just learned about this lovely function as that character that will take things and make them characters, right? So these are coming out exactly the same, and why is that? So dfsex2, right? If I say class, it's a factor. Okay, gender is also a factor. When you say as that character, it turns that factor back into just a straight character. No more levels, nothing like that, just words. Okay? Now, when you run table on that, intrinsically what table actually does is it actually factors something. It actually turns the thing into a factor. So what it'll do, it says, okay, I got characters in there, I'm going to do alphabetical ordering, F comes first. Okay? Same thing with sex2. Now, these two are different because this is a factor, this is a factor, but table will respect the levels that you gave it, or the levels of that factor. So, for example, in sex2, we said, I want males first in this table. And so table said, okay, you have a factor, you know what, I will respect whatever levels you gave it, so I'll put males first, right? Alternatively, gender had a different order of the levels, and we got that. Same exact table, just different orders. Does that make sense? So factors are not that important really until I think you get to modeling and maybe plotting for certain things. But here's the big thing. Data frames can have columns of like totally different things. Numbers, logicals, characters, whatever you want, factors. They can have all of them in a data frame. Matrices can only have one thing. They can all be logical. They all have to be character. They all have to be they can't actually even do factors, I don't believe. So logicals, numerics, or character, right? So that's very important to note, right? So if you say, oh, I have a matrix of stuff and I want a column of numbers and I want a column of something else, if for somehow in your operations it gave you a matrix back and you try to do that, it's going to say, I don't know what you're doing. But in honesty, what it'll actually do, it'll coerce things. So like, let's say let's do a matrix. Let's do a very quick example. Let's do Matt is a matrix. All I'm doing is making toy data. So Matt is just 3 columns. They're random normal data, right? Let's make it 4 rows. Oops, I have to do right. So it's got 3 columns and 4 rows. Now note, when I printed this out, I can tell you right now that it's a matrix and not a data frame just by the way it prints. Because if I had a data frame, right, we don't have these weird bracket commas and we don't have comma bracket type stuff. And so that's also an indication that it's not a data frame. Right, so remember we had df.
What's the purpose of having them in a matrix, period?
Certain plotting functions are good for matrices. In general, I would say it's not useful.
Yeah, because it seems like you can get away with everything mostly in a data frame.
Correct. Some operations that you perform may give you a matrix as an output, and you can convert it using this as.dataframe operation, right? So if you say as dot, right, you'll see there's a whole bunch of as, which will take, so the as functions do, in essence, coercion, intentionally, right? And they usually give you warnings. So like, let's say, for example, 5, 6, balloon, 7. That's R, right? I say as not numeric. R will say, I understand that, I understand that. I don't know how to make a balloon into a number, so I'm going to give you a missing value back. Okay? So, and that is why I wanted to introduce the word coercion, because it's actually in the warnings. Just be like, what is coercion? I have no idea what you're talking about. That's why, R just really strong arms. It's a very, very persuasive language. No. But, okay, back to the matrix example, right? We got this guy. So we'll talk about this function in a minute. So cbind, so it stands for column binding, right? So add something add another column. And it's important for matrices and data frames. To the matrix, Matt, I want to add 1, 2, 3, 4. So what that's going to do is it's going to add another column to that matrix. But the problem is this vector is characters, right? There are a bunch of characters in there. This is all numbers. So R is going to say, well, I don't know. I don't want to, off the bat, make those characters into numerics. So I'm going to tell the whole matrix, hey, we got some new stuff coming in. All you numbers, we're turning you into characters. So again, matrices have to have the same format throughout, the same type of object, the same the same class of object, and it will coerce it to that. And like I said, let's go back to this. This is a good. Okay, so mat2. Now, there is an inherent order in the classes of things, right? So I can do now C1, right? I can do that as well. Now, to this matrix that has a bunch of characters, I'm actually going to put a numeric. But R has an inherent ordering, right? It goes numbers, or like numerics are way at the bottom, and that's actually a subset of like integers and logicals, kind of. And then at the very top are characters. Characters is like, it's my last-ditch effort. I'm just trying to put it in some format that we can all understand. So if I do this, it's not going to say, hey, 1, 2, 3, 4, I'm putting in numbers. Everybody turn back the numbers. No, it's going to coerce these guys because these are characters, these are numbers, so kind of the lowest common denominator is characters. So it's going to put them all into characters. Again, this is usually not what you want to happen. That's why data frames are so important, because matrices are specifically limited, but they have purposes for that. They have reasons why they want to limit that, because a lot of functions that take in matrices, you don't want column 4 to be something totally different and break everything. But with data frames, you can do this. So let's say df. Remember df. And again, I don't use the viewer, and I don't think a lot of interactive users do. If you like the viewer, we can always use capital V for view. But head and tail usually give you a good snapshot of what's going on. So remember, df is these 30 children, age is gender. So I'm going to cbind, let's say, so I'm going to column bind the data frame with a new vector. And I'm going to make it some random normal data. Let's say the heights of the children, right? So, and I'll get to these like random, they're just random number generators. They're good for toy examples. A lot of times you don't need to use them unless you're doing like a simulation. But there are like functions, for example, that if you want to get like a p-value from a z-statistic, there are associated functions with that. But for right now, I'm just randomly generating data for illustrative purposes. Let's say the mean is, I don't know, 40, the standard deviation is 5. Okay, heights. And I'm going to actually name it. So it's like height equals this. So this is different, right? This isn't actually an argument in this function. It'll actually name a column what I said. So we'll get the cbind and rbind, like all the fun different ways you can do it. But now, let's say class df2 height. So what class do you think it's going to be? What do those look like? They look like numbers. They are numbers. Okay? So, although age is a number, gender is a factor. Sex too is a factor. Height is like we can still put a number onto that data frame.
Though.
Exactly. Right? So you can put in, and I can actually do this where like, I'm. Right. So in one statement, I can add in a numeric, and I use blah for a lot of things. But as you note, although this thing, I will show you what this actually is, and what this. This is just a character, but when you actually C-bind it to a data frame, it forces it to be a fact, which is a lot of times not always what you want. So I will quickly talk about this rep function. Rep means replicate. Right? So what that'll do is it'll take something and repeat it so many times, and you can do it in all the fun ways that you'd want to. Either you'd want to repeat like something 50 times, and then something 20 times, and something 30 times, or for example, male, female. You can do male, female, male, male, female, male, female, male, female. These are important. I can't think of necessarily right off the bat. Sometimes, though, for example, people do organize their data so that like the first 50 rows are the treatment, and then the next are like control. The next like 60 or something like that. So if you want to make like a treatment indicator variable, this is a good use of it. Saying like rep 0 50 times, and then adding on 61s, for example. That sometimes is an important thing. Usually people would have a treatment indicator in their columns, but sometimes they just organize their data in a way that they don't have an indicator for that, but this is a way to like make it, for example. But it just shows you just ways to like repeat things over and over again. It's not super important in your data sets, but I just didn't want to like throw rep in there for like no apparent reason, right? Okay, so again, C-bind stands for combine objects by columns. R-bind is the associated thing for binding on rows, right? So if you've worked with Stata, for example, this is for like R-bind would be the equivalent of appending. So just taking two data frames of the same, with all the same columns, and just attaching them together. Let's say for some reason you organize your sheets in Excel, one for site A, one for site B, but they have all the same columns, they're all exactly the same, and you have them now as data frame 1 and data frame 2 and R, and now you want one big data frame. You can R-bind them, right? So you bind them together, so you stack them on top of each other. R means by the rows, right? And then let's say
So you have like two different files.
if you have two different files, for example. Now this is not the same as merging,
Okay.
right? Binding together does not, like, let's say for example you have let's say you have a data set of follow-up data from patients, okay? Let's say you have a demographic data set. These are usually separate, right? Because they don't contain the same information. Also, sometimes you have repeated measurements from the same person. It doesn't necessarily make sense to have them in the same spot. So, you read in the demographics, you read in the longitudinal data. Now, if you C-bind them together, it'll assume that row 1 means the same thing in both data sets, and row 2 means the same thing in row 3. That's usually not what is the case. So there is a third operation called merging, right? That will merge on some identifiers, right? So this is kind of the Excel VLOOKUP stuff, or in Stata it's merge, and SAS it's merge or join. But there are instances where you've done something, or you've done some like summary metric, or I don't know, something where the rows mean the same thing and you want to bind them together, right? So that's what C-bind is good for. Okay, now the other big thing. So when I did df $blah or df2 $blah, okay, this is, so we're getting into subsetting, right? So what this is saying is df2, which is a data frame, $ means I want to pick one of the columns off, okay? That column I want it to be the block, right? To maybe more illustrate gender. So what that will return is a vector, right? Just that column that I wanted, okay? If I say class, it'll say factor. Okay? Again, I already knew it was a factor because when it says levels, I know that that object is a factor. Okay? Now, Matt, it doesn't even have any names for the columns. It doesn't even have any names for the rows. So, the way you do references for matrices is the matrix, a bracket, a square bracket, and then you can reference it by rows and then columns. Okay? So, for example, if I don't put anything in there, and I do this, I'm implying that I want all the rows, and I want the first column, or the second column. So that's extracting or subsetting from the data, right? I'm picking out something from the data that is not the entire thing. Or it could be the entire thing, but really it's usually picking out one of the columns. Let's say I wanted the second row. Different syntax. This is referencing rows. Then I say I want all the columns. Okay. Now, the reasons why we talk about matrices and data frames together is that operations that you can do on matrices, usually, almost all of them, you can do those operations on data frames, but specifically subsetting, right? So let's say I want the first column of a data frame. I can still do that, right? I could still say, so a data frame is a matrix, but a matrix is not a data frame, okay? So, and if I want the first row, I can do that as well. Now, here's the big difference. One of the big differences, at least, right? In a data frame, the columns are always of the same type, right? Because it's a column of stuff. Like age isn't like, the first person's age is like a number, the next one's like something, like some word and stuff like that. But in the rows, it can be very different. So, if I say the class on this is a number, right? These are the ages. But if I say the class on this actually returns another data frame. Because even if they all were the exact same type, even if they all were numbers or characters or whatever, it says, hey, this is a data frame. I'm taking off a row. I don't assume you want to collapse these things together because usually that doesn't make any sense. So I'm going to return an actual data frame for you. Does that make sense? So it is important to note, though, that when you subset a matrix in either direction, because it's inherently and specifically all the same type, it always gives you a vector. Data frames, when you subset columns, they give you vectors because we know in that column they're all the same. They're all the same stuff, right? If it's not all the same stuff, then everything doesn't, and nothing makes any sense, right? But with rows, it gives you a data frame back. Okay. And we talked about this lovely function, subset. So subset, again, takes in data frame. And then the nice thing about it, okay, the other thing I want to show you, there is we said age, right, like 3, 6, or 10, right? So the way you can also do that with the subset, the syntax we just talked about. Okay, so logicals, so either you can put in the row numbers, right? So 1, 2, 5, 10, 11, or you can pass it in a logical. Say, do you want this row? Yes or no, right? So actually what you can do is this. So what is this doing? This seems like a very complicated statement, but it says, I want to grab the age vector from the data frame, and I want to test, is it a 3, or is it a 6, or is it a 10? And if that's true, I want to pick out that row. And I know I'm picking out rows because this indexer, right, comes before the comma. So I say data frame, subset using this guy on the rows. Does that statement make sense? So it gives you the exact same thing. So the one big difference between these two, I would say, is this part right here. So subset will take df, and if there is a column called age, it understands this completely, right? But when you actually want to subset a data frame using this syntax, you have to grab that column from the data frame. So if I do this, maybe this is a good example. R will look in its environment and say, I'm going to look for this object called age. Okay? There's no object called age in here. So it says, I don't know what you're talking about. This statement, on the other hand, says, I want to take the column named age from this data frame. And then I want to subset on that. This is a different style of syntax in the sense that you put in the data frame, and the column names of that data frame, you don't have to put this $sign stuff in there. It'll still work, right? You can still do that. It's okay, but you don't need to. And that's the nice thing about it. And a lot of people coming from different languages, you're like, why do I have to grab the column name over and over again? Shouldn't R know that I'm working on this data frame, right? And this subset function allows you to do that. Whereas if you actually use what I'll call subset syntax, it may not. But in some instances, there are times where you make a vector that isn't attached to the data frame. You make it on its own because you actually want to change it around or something like that. And that was like, so when I downloaded the Baltimore City the circulator data, but I actually downloaded some of the real estate property taxes, and I wanted to do operations on maybe, for example, only the data where it was measured in square feet versus in acres versus in certain different formats. So I might have had, for example, like, here, let's do this. So my log index, right? So let's just df age in 3, 6, 10. So now this is saved in R, in memory, in the workspace, in the environment. So R knows my log index. And that I called that for my logical index, right? So again, it's just trues and falses for when the age in df is 3, 6, or 10. Okay? So you can still do that. So in some instances, you may want to create this and then run it. Because you might want this later, right? I don't know why. This isn't a really illustrative example as to why you might want that. But, maybe you do, and this actually... Right, so for example, how we were saying you can column bind to different data frames, right, where the rows actually do match up. Maybe you want to make this index, and you want to apply it to both data frames, for example, right? You can still use the subset command, but there are some times where, if, for example, though, this data frame for some weird reason had a column called my log index, that would override this thing. So like, okay, so it's false for everything, right? Which means it's never true. So this function goes into that data frame and says if anything over here, if anything that's like named, so for example age, or just it's like an object, right? So something that is not like numbers or a vector or something like that. Anything over here, it says if that exists, I'm going to go look into the column names of the data frame, right? And so, for example, when we did age, this. Age is not in memory. Age is not over here, right? R does not know. If I say age right now, R has no idea what I'm talking about. There's no object called age. You can't find it. But when you use subset, it says, I can't find age, or I'm going to look in the columns of DF, and let me see if I find age. If I find age, I'm going to use that. Okay? If I cannot find that, if I can't find age in the column names of the data frame, I'll look in the rest of R. I'll look in the rest of what R's got. Right? And in this instance, it had age in there, so all was good. Does that make sense? Now here, the same thing happens. Subset will look through all the column names of DF. It'll look for my log index. If it finds it, it'll say, I'll use that column to subset the data. Great. There is a column called my log index, and they're all false. Okay? This, on the other hand, because I don't have any DF $ stuff, it says, I think this is just a normal R thing. I'm going to look in R, and I'm going to look for my log index, and that's stored in memory. So what I'm trying to say is this is doing this by default, right? Versus this, which is just saying, like, this is just some R object, right? It's not attached to any data frame. It's just something. I'm looking for R. I'm looking for something called my log index, and I'm going to use that. So it's a little bit confusing, but it's important to note that the subset command is great, and it will look in the column. So you don't have to use this $sign over and over again. But if, for example, if you happen to misspell something, or if you weren't very clever in naming some things, like let's say, for example, you have dfx equals like true, right? And then you name something like df. Oh. Right, something like that. Excuse me. Right? You say subset dfx, and you actually want to subset by the thing you just made. You have to know that inherently it's going to look in the columns first. It's going to get every single thing back. Right? So just understanding that this syntax is a little bit more convoluted, but it is a little bit more explicit in some respects. So now you can also do fun things. So right, now we got subsetting rows, okay? We've subset rows. Now the same thing, we can say we can subset columns, okay, and rows at the same time. So this on the right-hand side, after the comma, says, I want this column, okay? And you'd put in the name of the column. So this, okay, so this operation here takes the data frame, subsets the rows, and subsets the columns, okay? Does that make sense? This operation here is going to give you the same exact thing. The only difference is it picks off that column, that column first, right? And then does the subsetting. So, okay, if I do this, it's going to give me back all the sexes of that variable. And then, so this is the big difference. So, matrices, row, comma, column. Right? That makes sense? We're all clear on that? Vectors, let's see. And data frames can do row, comma, column as well. Right? Vectors are just index. They just have, remember, they only have one dimension. They don't have rows, they don't have columns, so you just pick off the ones that you want. So you can either do that two ways, right? We can either did it like we did before, using some number some index, or we can use a logical statement like we did before. Okay? All right, so let me go over, okay, we've gone through most of this. We'll talk about seek in a little bit. So we've gone through most of the modules. So module 3 may be important to kind of maybe go through just a little bit on your own, but we've covered mostly all of it. The one thing I do want to talk about are these other functions that we haven't really touched on. We've touched on length, we've touched on head and tail, right? Getting the top and the bottom of a matrix or a data frame. We've briefly touched on table, and I'll go into 2 to 3 minutes on that in a second. We've talked about subset and kind of bracket notation. I'm gonna do another module very detailed on that. Unique, right? What do you think unique does?
Choose only a specific characteristic.
Exactly. So, but it actually will return the unique values of something. So, for example, let's do this. Let's make we're gonna say rep male 5 times m 5 times okay. So this is how some people encode their data in some very interesting ways. But let's say instead of like 30 of these, you had like hundreds. Unique will just give you the unique values in there, right? It doesn't count them. It doesn't tell you how many of each of them there are, but it just tells you out of this whole vector, what are the unique values, right? In this case, it's male, all capitals, M, female spelled with lowercase ale and then an F. Okay? Table can do, usually, it can either take one vector or 2 vectors, right? Whether you want to do just a standard table, or if, for example, you want to do a 2-dimensional table, right? So this is saying, of the, let's say, age on top, right? So it usually goes things on the rows, things on the columns, okay? So it says there, we know there's 10 Fs, 10 females spelled this way, 5 Ms, 5 males spelled this way, okay? So, but it's just telling us actually what are the ages broken down by each one of these categories, right? So it's just a standard table. It's just 2-dimensional versus 1-dimensional. So this is really important when you want to do, let's say, gender and, I don't know, any categorical versus any other categorical variable, right? Or like age categories, for example, and gender, or treatment and any of your categorical variables. So whenever you want to do Fisher's exact test or chi-squared tests, these are the things you want. And actually the fun thing is Fisher.test is a way, and chi-sq.test, right? This is Fisher's exact test on a table, right? So this is when you want to see if like the rows are independent of the columns. This is a really bad, really bad example because this table doesn't make much sense. Okay, but let's say, excuse me, table df gender df. Remember I made this random normal thing. It's greater than 40. Oh no. Oops, I made that on df2. Oops. Maybe 38. Okay. So here's gender we made this random height variable, right? And we wanted to do a table to see how many males, how many females were above 38, whatever I made up, whatever units. So now I can save that, right? So tab is now a table. So what if you want to do testing on this? So now we're getting a little bit. Into statistics, right? If you want to do a Fisher test to say whether if the height's over 38, and is that related to gender or not? Yes or no? So Fisher's test, Fisher's exact test, one is good for small sample sizes. It's good for categorical data, and it'll tell you. So the p-value is 1. Right. This should not be surprising whatsoever because we randomly generated these heights. Right. There's also the chi-square test. But the nice thing about this is it tells you that the chi-square test approximation may be incorrect. And that's because, if the expected sample size in any of these cells is less than 5, then usually the approximation is pretty bad. So, anyway. That's a brief rundown of table. So you can do, and then there's a nice, we'll talk about it. Prop.table will give you proportions.
So the difference between chi and the Fisher exact test is that chi gets 2 categorical while Fisher exact test.
So they both test the same hypothesis. Chi-square, Fisher's exact test, for almost any 2x2 table, Fisher's exact test should be used, in my opinion. The only reason Fisher's exact test though does go to any m by n table scenario. The problem with so Fisher's is exact, whereas chi-square's is approximate. So chi-square you have to assume like your sample's kind of big, asymptotic normality, that kind of stuff. So big sample size stuff. The problem with that is when you do have relatively large sample sizes, the Fisher's exact test is very, very computationally intensive to calculate. And in that case, you already have large sample sizes. The chi-square is probably going to be a good approximation. The big problems are when the individual cell counts, the expected values in them are very, very small. So even if you have like 1 million people, if the way you categorize your data, a couple of those cells will like never have values, for example, or very, very small values, that approximation still could be bad. But so prop.table will do a lot of the times what you want to do as well. Let's say instead of this is, let's say this is how you defined your group, right? Over 38 centimeters or something like that. I don't know what you're doing. But let's just say 38 was a fun number that you got. Or think of it as treatment. So you say prop.table, this will divide by the total n and give you the proportions in each of those cells, right? So for example, tab, sum, if I say sum on tab, that'll give me the total sample size. So if you say prop.table tab without any other arguments, it's essentially doing this. It takes the table, it divides by the sum of the table, right, which is the total sample size, and it gives that back. A lot of times it's not what you want. What you want to do usually, and it's very important. You remember how I said row, comma, column? Right, over here for the subsetting?
Yep.
So R thinks rows are the first dimension, okay? The first dimensions of a thing. And columns are the second dimension. So that's important to know because if you say prop.table, there's this thing called margin. So what do you want to do the proportion over? So if you say 1, what that's going to do is divide each row by the sum of that row. So for example, this now doesn't represent the proportion of females who are under 38. This represents, right, which was 16%. This represents of females, conditioning on only females, what proportion of them are under 48? Are under 38? And that's 29% versus 16%, which is over the entire group. So these rows now should add to 1, right? 100%, right? So you're dividing really by the row totals in margin equals 1, right? And like I said, R thinks rows of the first dimension, okay? So if you say 2, this is different. This is saying of the children who are under 38, what proportion of them are female? And that's of the under 38, 55% of them are female, versus of the females, 29% were under 38, right? So these are very helpful when you're constructing tables for like demographics and that kind of stuff. Okay. Also, not surprisingly, these things should be very clear on what they do. Sum, they mean, they median, min, max. I have shown you head and tail many times. STR, I don't use it that much, but it is a kind of a snapshot view of an object, and it is relatively good for data frames. It's saying what is the structure of this object. So it tells you it's a data frame. It tells you how many rows. It tells you how many variables. It tells you the column names, and it tells you the type of them. Right. So it says gender is a factor with 2 levels. My log index is illogical. It's all falses. So STR is also sometimes very helpful, but I don't use it that much. We've used head and tail a bunch of times. Table, we show you in table 1 versus 2. Again, if it's a factor, it'll keep those levels the way you want it to, so the rows will be all good. So this colon syntax, what is this? We've talked about this a couple times. So 1:5, we'll do a sequence from 1 to 5 by 1. There is a seek function, which is much more robust in the sense it can do other things. This is really, really just a shorthand for sequence. A lot of times you want to do a sequence that are counting by ones. Other times you really want to do it in some specific way. And I recommend using seek as much as you can because that's probably the safest way. Also, sometimes you want to do things by something other than 1. So, for example, here I wanted to count to 5 by 2. Note, though, it doesn't always, if it doesn't make sense. I mean, it'll do the thing that makes sense. Sometimes the stuff you put in doesn't necessarily make sense, right? But just note that it won't always end at your endpoint, the one you're trying to go to, if it can't. Right? You can't go to 1 to 5 by 2.5 and end on 5. It's not possible, right? So seek is a way to make sequences of things. And in general, its default is by 1. So we did this. It's the same thing as this. But a very, 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 very important thing. So if I want to go from -1 to 5, I can do that. But if I want to go from 1 to 5, but them all be negative, it's that. Very important on how you group the terms. But it's much easier to see. You say from equals -1, 2 equals 5, or that is much more explicit. You're less prone to make this kind of error, which is very problematic because that's usually might not be what you want. It may be what you want. It may not be what you want. So just be very clear on like what you really are trying to do. That's why I think seek is a lot better. Okay. So again, if you want to subset multiple indices, you have to use this C, right? So remember, so I said data frame, rows, comma, columns. Let's say I wanted the third row and the 5th row. This is not what that will give you. That's saying I want the 3rd row, 5th column, right? Because remember, row, comma, column. Now, this will tell me I want the 3rd row and the 5th row. Does that make sense? Because this is a whole collection of indices on the left-hand side. Then it says comma to denote those were all the rows. Now I want to say which columns, right? And so now I can say the first column, the first and fourth column. So you have to collect or combine things for indices, for subsetting. You can't just leave them bare unless they're singular. Okay? Unless they're just like, you want one row. Anything more than one, you have to combine them together. So I've already talked about these. I haven't talked about column names and row names just yet. I don't think they're necessarily that as important as some other things we talked about. Again, we've talked about data frames and subsetting them, head, and how to actually subset by the $sign. Like I said, so you can actually subset sex2 by the $sign, or you can use that. The only thing is, if you want to subset multiple columns, you have to use this type of syntax. That's why it's important. Okay? So if you want 2 columns, and also note, the order in which you put them in, like even though like age comes first in the actual data frame, you can subset them in a way that the first column is now sex2. So you can reorder your columns in that way if you want. So anything, if you want to subset one specific column in a data frame, $sign is very helpful, especially because when you say df $sign, it gives you like a whole list of the column names, so you don't like misspell anything. But if you want to subset more than one column, you have to use this type of syntax. Okay. All right. So this is kind of what we were talking about here. Same idea. We'll talk about constructing data frames a little bit later, but for the most part, you guys will read in data and it'll be a data frame. There are other instances where you might want to create one, but there are two other data types that I didn't talk about. So some they're called ND array, or they're n-dimensional arrays. So like for example, if you had a 3-dimensional object, like for example, I do brain imaging, and the data we read in is 3-dimensional, right? Almost never will you have to encounter that in R. Ever use that. The only times that might be useful is crosstabs. So for example, if you want a 2x2 table over a third variable, right? That's actually technically 3-dimensional, right? So 2x2 by something. And lists. And we will get in a list. They are very, very generic. They're just things that can hold like anything. Like lists can have elements, like element 1 could be a model, element 2 could be a matrix, element 3 could be a data frame, element 4 could be another list of lists of lists. So they're very confusing, but we will touch on them a little bit, and some other generic objects like a linear model, like that type of object. But you don't really have to worry about lists too much in your day-to-day. But data frames are, again, the bread and butter that you'll be working on. So it's 2 on the dot. Hopefully that's been kind of clear. The subsetting can get kind of confusing.